Alright, in previous lessons, we found slope of linear equations and functions using the slope formula. This is going to be super important to what we're doing today. We've also identified the slope of a line from an equation by rewriting it in slope-intercept form and identifying the m, where m is your slope. By calculating the slope, we're able to determine what's called the rate of change. Right? It's the ratio that describes how much one quantity or one variable changes with respect to the change in another variable. Okay, so in other words, how much is y changing with respect to x? So the rate of change can be determined from graphs, tables, and equations themselves. In this lesson, we'll extend that understanding to exponential functions, because you can find what's called an average rate of change between certain intervals for an exponential. You won't be able to find a constant rate of change like you do with linear, right? The only rate of change, but you can find a rate of change between 2 points. Okay. Again, read all these key concepts. I'll scroll down to see you get them all. Okay. Make sure you read those. I'm not going to read them to you. Pause the video if you need to. There's a couple more. I will focus on these. If you find a rate of change of 0, that means that it's a horizontal line or a flat line. Okay. If you find a vertical line, right, that has an undefined slope. Basically, that means you're going to have 0 in your denominator. Right? Which means it's not a function. So, all right. Example 1. Janie invests $1,300 at a rate of 2.6% compounded monthly. Okay? The function that models the situation is given here, and x represents time in years. What is the rate of change for the interval 1 to 4? So when x is 1, when x is 4. So basically we're saying when x is between 1 and 4. Okay? What's that rate of change? We don't have a graph, so we can't look at the graph and kind of see it. So what we need to do is get a couple of points. We need to get x1, y1, and x2, y2. And now they were nice enough to give me that my x1 is 1, but they didn't tell me what y should be, and 4. So I need to use my calculator or use my ability to plug functions in, or points in, to figure that out. So I want to find f of 1, which means I'm going to do 1,300 times 1 plus 0.026 over 12 to the 12 times 1 power. Okay? Now, when you do that, which you should use your calculator for, when you do that, you get 1,334.21. Okay? Sorry, I kind of crammed that in there. And then I need to do the same thing with 4. I need to plug that in. So f of 4 is 1,300, 1 plus 0.026 over 12. Again, 12 times 4. Okay? And again, I'm going to use the calculator for that, because this is something you're going to be able to use your calculator to do all the problems on. And here at that point, it turns out to be 1,442 and 32 cents. So 1442.32. Right? So what we want to do now is we want to find the rate of change between those. So we want to do y2 minus y1 over x2 minus x1, which means we're going to do 1442.32 minus 1334.21 over 4 minus 1. Don't worry, they won't all be equal to decimals and that kind of stuff. When you do that, we get 108.11 over 3, which turns out to be 36.04. Now, since we had context for this problem, we need to make that answer make sense in context, which is what was going on here, right? What was the original problem? Okay, it was investing money, and it's over the number of years. So there is $36.04 per year. So we can change. All I need from you is the context, right? So per year. I'm not asking for a sentence right now or you to explain what that means. I'm just looking for the units basically to go with that answer. All right, so that is your average rate of change between 1 and 4. Okay, since it's exponential, if I were to pick two different points, say between 2 and 10, you would expect to get a different rate of change. Okay? We'll talk about how to compare and that kind of stuff a little bit later. Alright, so example 2. In 2008, about 66 million households had landline phones and cell phones. This number decreased by an average of 5 million households per year. You said we'll calculate the rate of change for 2008 to 2011. So, X1, Y1, X2, Y2. This one was pretty easy. Nice little setup for us. So what we want to do is 51 minus 66 over 2011 minus 2008. Okay? And when we do that, we get negative 15 over 3. Alright? And so then, when you divide that out, you get negative 5. And so the question is, what does that mean? The rate of change is 5 million, it's actually negative 5 million per year. Right? Rate of change okay? Or you could also say it's decreasing by 5 million households per year. And we already knew that, okay? We knew the average, and this is linear. That's the deal. This is linear, going down by 5 million each time. Now, that example leads us into the next one, okay? A type of bacteria doubles every 36 hours. A petri dish starts out with 12 of these bacteria. Use the table below to calculate the average rate of change, okay, for the interval 2 to 5. Again, if they give it to you in a table, don't beat yourself up. It's not real hard. Okay, x1, y1. The other interval is x2, y2. Okay, so to calculate the average rate of change, we're going to do y2 minus y1, so 121 minus 30, and then x2 minus x1, which is 5 minus 3. Not 3, it's 2. Wrong point. Alright, so when we go to calculate that, we're going to subtract it out. 121 minus 30 is 91. 5 minus 2 is 3. And when you do 91 divided by 3, you get approximately 30.3. Alright? So, what does that mean? The rate of change is approximately 30.3 bacteria per day. Okay? Rate of change is approximately okay, good. These should be two relatively easy lessons for you. So now that you got this one, go ahead and go on to 3.3.3. That deals with rate of change as well, specifically from graphs.